All right. Good morning or good afternoon to everyone, and welcome to today's webinar, Mass Timber in Housing, Aesthetics, Affordability, and Sustainability. My name is Marcy Weaver, and I'll be your education team moderator for today's presentation. Today's webinar will run 1.5 hours. Today's panel consists of Kevin Naranjo from USDA Forest Service, Tom Chung from Leers Weinzapfel Associates, and Susan Jones from atelierjones LLC. This course is copyrighted and not eligible for reproduction. Please note that this webinar and associated slides should not be used as a substitute for competent engineering support and expertise. Hopefully most of you have already read the course description when you signed up for the course, but here's a quick glimpse of it again. We'll be covering the use of mass timber as a green solution for low-cost, affordable housing, and also look at a couple prominent mass timber projects in Seattle and Boston. Again, you hopefully saw the objectives when you registered, but by the end of this program, you should be able to recognize efforts to promote mass timber investment opportunities, explain why mass timber is a viable alternative for affordable housing, describe how mass timber can overcome challenges related to urban infill construction, and discuss why mass timber is a feasible option for both large and small projects. And here's the behind the scenes team that's providing this course for you today. Our engineering moderator today is our Director of Educational Outreach, Lori Cook, and all things education and certification is provided by myself, Manager of Education and Accreditation, Marcy Weaver, and our Education Administrator, Kim Paulson. Our panel today will begin with Kevin Naranjo discussing the Wood Innovations Program and the current state of mass timber projects. We'll then hear from Tom Chung discussing an affordable housing neighborhood in Boston. And lastly, Susan Jones will close us out with a discussion of sustainable carbon mass timber housing. So now let me start by passing you over to Kevin.
Good morning. I'm Kevin Naranjo. I'm with the U.S. Forest Service, and I'm going to talk about mass timber in housing. Primarily, I'm going to talk about what the Forest Service has been doing to support mass timber over the last 7 or 8 years. So at USDA Forest Service, I work in our cooperative forestry in our Washington office, and my emphasis is on our Wood Innovations Program. And the goal of our Wood Innovations Program is to support and stimulate wood product and wood energy markets in the U.S. The focus of my discussion will be around mass timber, which is certainly a wood product. So with our program, primarily we have two grant programs that we initiate every year: Wood Innovations Grants and the Community Wood Grants. It's the Wood Innovation Grants that allows us to be able to fund mass timber projects, either construction, design. But in the last year, there's been some additional funding for our program through the Bipartisan Infrastructure Law, and most recently the Inflation Reduction Act. And we use these in different ways to stimulate wood product markets. The Bipartisan Infrastructure Law, we were able to fund additional grants last year to our wood innovations and our community wood. And just briefly, I won't talk much about the Community Wood Grant Program, but with that program, we can fund actual equipment. That might be sawmill infrastructure equipment or wood energy equipment. We can't do that. We don't do that with the Wood Innovation Grant Program. And just a kind of a quick slide that shows we have funded a lot of projects throughout various parts of the U.S. Since 2015. And you can see a lot of them occur in the West, where we have the high fire risk areas. Since 2015, we have funded 143 projects related to mass timber. Last year, we were able to fund 35 projects, 78 total wood innovations, and 35 that had some connection to mass timber, which is really, really great. We're hoping, again, this year and the next couple of years that we're able to keep up. Congress is good to us, and we can still fund that many projects. We also did some other funding, and I'll talk about that stuff as I go through my presentation. And this is just kind of a neat slide that Woodworks developed. It kind of shows how mass timber has taken off in the last several years. As you can see, in the last few years, we've had kind of an exponential growth in mass timber. I think that we're starting to get to a tipping point where we're going to see more and more mass timber projects in cities throughout the U.S. And ideally, we'll start to see some more manufacture. And how does the Forest Service, what is our strategy to be able to support mass timber? We have 4 primary areas that we focus on. So we support education, technical assistance, we've supported research and code, and then actual some initiatives, some projects that kind of really highlight and bring greater attention to mass timber. And since 2014, the Forest Service, we've invested over $55 million to be able to support mass timber in the U.S. And I can tell you that I think our work isn't done yet. I think there's a lot still to be done, a lot of room for growth still. And as I go through the presentation, I'll give examples and kind of talk through the pieces for each of these focus areas. First one, education. I just want to point out that that building is the Andy Quattlebaum Outdoor Recreation Center at Clemson University. That is built with southern yellow pine. That was the first southern yellow pine mass timber building east of the Mississippi. But we funded Clemson University a grant last year to be able to develop a training curriculum for a combined training curriculum for architect students, engineering, and forest product students. Clemson partnered with the Saltwood Lumber Board and Woodworks to be able to implement this program. But the training, what's kind of unique about it is during the school year, it'll be for students, and then in the summer, it'll be opened up to the actual construction and engineering architect community, professionals who are applying the trade now. So, and this is something that the Saltwood Lumber Board, our partner, has a strong focus on, and I think we'll see potentially with over time with other universities. And I think that that's really great. That's where we need to see a lot of education of new students, not just current practitioners. Think Wood Mobile Tour. We helped fund that again this year. That's an initiative led out by the Saltwood Lumber Board and Think Wood. And the Think Wood Mobile Tour, they do partnership with the AIA to be able to take this wood product, little mobile wood product around to universities and also to events in wood product events in the U.S. This has been a very successful program. And brought a lot of attention to wood and to mass timber. We help support the Mass Timber Conference. My supervisor, Brian Brashaw, has been part of the development of the Mass Timber Conference, along with Woodworks and other partners, to be able to develop the agenda, help carry this out. Technical assistance, and that building is until recently was the tallest building in the U.S., the Carbon 12 building. So we provide technical assistance. Probably, these aren't my words, but I strongly agree with it. The best investment that the Forest Service has made to date over the last several years was our funding to Woodworks. Woodworks is probably the strongest partner related to technical education for architects, engineers, and developers to be able to build and answer questions around mass timber. So we're very excited to continue that partnership into the future, along with, again, the Saltwood Lumber Board. We have funded over time several state wood innovation teams, but two of the more successful was ultimately became the Clemson University's Wood Utilization and Design Institute. They brought attention to mass timber in both the southern region of the U.S., but also elsewhere in the U.S., and they've done a lot to strengthen education around for students. And then the Tallwood Institute in Oregon has been another successful statewide utilization team. Research and code. So a lot of our funding goes to support partners who are doing research for mass timber. We helped support different partners, and ultimately, which led to changes in the 2021 building code, which allow tall timber buildings up to 18 stories. And most recently, we've supported fire testing of partners that help make changes to the 2024 tall timber portion of the IBC, which allows exposed mass timber up to 12 ceilings up to 12 stories, which is really great. We've done fire testing. This is at the Forest Products Lab. We've also supported fire testing with other partners as well, which all have led to those changes in the big part of leading to the changes in the code. And most recently, we're supporting the 10-story shake test that is going to take place soon in at San Diego. This will help bring strengthen new opportunities along the earthquake zones in the West and give greater confidence to building and code officials for mass timber for tall timber buildings. Special initiatives. This is the University of Idaho ICC basketball arena. We funded in 2019 in partnership with the U.S. Endowment. We supported a competition for universities. So 10 universities received funding to be able to support mass timber projects, and that was most of those turned into buildings, which was really great. This is just a beautiful example of mass timber, and it drew a lot of attention throughout the U.S. Last year in 2022, we partnered with the Salford Lumber Board, and the Woodworks again helped lead out this net zero mass timber competition, which focused on low carbon timber design. Six buildings were awarded, and the total award was $2 million. And next year in 2023, we're going to partner again with the Salford Lumber Board on another mass timber competition to bring attention and highlight mass timber in different parts of the U.S., which is again another really powerful initiative that we're trying to support. In 2022, we were contacted by the Boston Planning and Development Agency. They will be adopting the tall timber, the 2021 tall timber code in November of this year. But they wanted to make mass timber a strategic part of their sustainability strategy to get to net carbon zero by 2050. And in doing so, they wanted to be able to incentivize developers and architects to consider mass timber. So we partnered on what they referred to as an accelerator project to be able, and there were 7 winners, and they've gone back out and they're going to select 3 more projects. We are working with the City of New York on a potential accelerator project. We're going to partner with the Georgia Forestry Foundation to do an accelerator project in Atlanta, and hopefully in other cities either next year or continuing throughout the years. This was a very successful project, brought a lot of attention to mass timber in the city of Boston. It really opened up developer and architects' eyes to the both the economic and the carbon savings possibilities of mass timber, and brought a lot of attention to the city. So we think we're really excited about that project, and we think we'll be able to have other successes in cities in the U.S. Affordable housing, which is kind of what this is about. We have, in the last several years, we have funded close to 10 to 12 projects that have some aspect of affordable housing. This is the picture of the Adult Residence Hall in the University of Arkansas. The University of Arkansas has been a strong leader in mass timber. They have this building they built, and then they did a library storage unit, and they're focused on a new combined architecture engineering building that they're going to be building soon. But we gave a grant to the University of Arkansas for a housing innovation center. So they really want to see how mass timber can support. There's throughout northern Arkansas and other parts of Arkansas, there's a shortage of affordable housing in rural areas. So they wanted to, they're working with communities to be able to understand and better bring the right size housing utilizing mass timber to those areas. Recently, we gave a second grant to the University of Arkansas to hold an affordable housing consortium workshop, where they'll bring together partners that we have funded through our Wood Innovation Grant Program on affordable for projects that will have affordable housing, as well as other partners throughout the U.S. We think that this will help because mass timber. There's a lot of discussion that it can be a great solution to solve some of the affordable housing crisis that we have in the U.S. And so this is just another way that we think that we can help partner and bring attention of universities. We can bring practicing professionals, developers, ideally cities, to kind of come together and talk about this issue in kind of a unique environment. And some of the projects that we have funded we funded Alan Organsky a grant, and this project 340 Dixwell Avenue is just coming out of the ground. This will have affordable housing in the city of New Haven, Connecticut. What's really interesting with this project is in their work with the city, the city has identified green zones, and as a result of the work that Gray Organsky did on this project, the city included mass timber as part of the solutions to be able to get to net carbon zero in these green zones. So another project that we funded, I think this is neat because this is in Des Moines, Iowa. So we fund this. This is Junction Catalyst Development. It's a project in the city, and it's affordable. It'll include affordable housing, and they built this out of mass timber, and we gave them a grant last year for another project, the Star Lofts, which will include affordable housing. I kind of shown this picture because they built this so it fits within the kind of the because the neighborhood, the area, they were kind of particular about the way it looked, and so this building will fit nicely within the look that the city has. But these kind of nice that we're doing projects in smaller cities as well as larger cities. And then it's kind of just a list. We have funded a lot of different partners in the last several years on projects related to mass timber. Susan Jones has received several projects. I know she's talking here on this call. As another big project is the project that Kaiser Path has been doing in Portland, the Seedlings to Shelter. So we've seen a lot of interest in affordable housing through our grant program, and I think we'll continue to see that over the next several years. And we're very excited to be able to fund with our grant program projects that can help resolve some of the issues related to affordable housing in the U.S. And lastly, I would be remiss if I didn't show this picture of this is the Forest Supervisor's Office on the Nez Perce Clearwater in Kamiah, Idaho. This was the first building the Forest Service built out of CLT. We have another building that the Forest Service is looking at in Tahoe, the Tahoe Supervisor's Office. But what's really is that more important is that the federal government now has a net carbon zero goal by 2050, and GSA will be looking at mass timber as a solution to their new buildings to be able to get to net carbon zero. So I think in the future we're going to see the federal government and ideally more state governments looking at mass timber. And just upcoming grants, I think some of these dates may have changed since I put together this slide, but we have coming out a wood products infrastructure grant, which will support actual infrastructure for facilities that use wood. But our wood innovation grant and our community wood grants should be being announced this week. And then next year, we're hoping to be able to use the IRA funding to be able to support additional wood innovation grants. And with that, that ends my presentation. And thank you.
Thank you, Kevin. Wood Innovations is doing great stuff. Now let's transition to Tom Chung and his presentation on affording mass timber for affordable housing.
Thank you for joining us as I share about why I think mass timber should and can be used for affordable housing. I'm Tom Chung, principal at Leers Weinzapfel Associates and professor of practice in architecture at Auburn University. The presentation agenda is that 1, I'll be stating the case for why mass timber for affordable housing is necessary, a strategy of how we can afford mass timber for affordable housing, and then share a case study of a project in design, the Elliott Church Affordable Housing Project. The work I'm presenting is a collaborative one, that of our firm Leers Weinzapfel Associates. We are a 30-people design firm based in Boston, Massachusetts. And with all our designs, we strive for our core values, regardless of project size and type. We aim to bring the value of design excellence, focused on the human experience, sustainability, and craft of building to ensure a solution that is right and appropriate for each project and client. And with every project, we respect our client's budget and schedule and design to that. We like to call it responsible design excellence. And as much as we believe in the value of design, we believe in an equitable and just practice in our work, giving back to our communities near and far, and in our practice, having a diverse group of architects and designers, and proud that we are a majority women in overall staff as well as leadership, and with over 35% minorities. So why mass timber for affordable housing? We know that wood is fundamentally sustainable since trees grow, and as it grows, it takes carbon from the atmosphere and stores it. In addition, the overall embodied energy or carbon emissions of building with wood, from extraction, processing, transportation through construction, is much lower than other building materials such as steel or concrete. We explored these in our 2 large-scale build projects, the Adobe Hall at University of Arkansas on the left, a student housing project which was completed in 2019, was the largest cross-laminated timber building in the U.S., and the Oliver Design Building at UMass Amherst on the right, completed in 2017 and among the first large-scale academic mass timber buildings in the U.S. We explore the potential of mass timber to create special places for gathering and building communities, all the way down to the most private of the spaces, the student dorm rooms at Adobe Hall, and the studio spaces at the Oliver Design Building. And the mass timber components we used were primarily glue lams for columns and beams, and CLT or cross-laminated timber panels for floors, roofs, and walls. We took advantage of the cutting-edge technology resulting in the precision and high quality of such materials. Here we see images of a CLT factory, highly automated with large-scale machinery such as this press, and the CNC machines that allows wood to be used to produce large-scale buildings for growing urban centers. But there is a cost to such technology, with investments in CLT factories being in the tens of millions of dollars. And while that isn't a factor in large-scale projects that compare with costs for steel and concrete buildings, for very small affordable building projects such as ours, which must compare to light frame wood construction, there is a cost consequence to the investments in this technology. And in addition, as we consider the embodied energy of material production, and in the case of wood, timber harvesting to debarking, and lumber production, which often is the base unit for the various mass timber panels. In the case of CLT, additional drying of the wood, planing, finger jointing, gluing, and post-production machining, all of which has cost as well as carbon footprint implications. We said, for such a small affordable housing project that must compete in cost to a light frame wood construction, how could we not absorb this additional cost as well as the carbon impacts of a mass timber product that is highly specialized like CLT? That is, looking at the embodied energy, could we reduce the carbon footprint associated with processing and perhaps even transportation? Again, I must be clear here that the project type and the very small size of the affordable housing project which I'm about to share is what made us look very closely at the specific mass timber product to even further reduce the cost and carbon footprint of otherwise what is a very sustainable material such as CLT and other mass timber products. So in affording mass timber, we went back to the base unit, the very common lumber which is the basis of our light frame wood and many of our mass timber products. And in looking at an array of common mass timber products, we investigated nail laminated timber, which is the closest in relationship to lumber, as it is simply lumber 2x4s and 2x6s mostly, which have no further post-production other than nailing them together without involvement of expensive machinery, which could be produced nearly anywhere and by hand in sizes small and large, and used in many of the ways materials like CLT are used, such as floor and roof panels, and one which sequesters as much carbon and has the same biophilic qualities of wood that make wood spaces that promote user well-being. So investigated this approach in our case study, the Elliott Church Affordable Housing, which we just completed in concept design. This was made possible by the Boston Mass Timber Accelerator Grant Program from the Boston Planning and Development Agency, the U.S. Forest Service, and Softwood Lumber Board. The project is located in Roxbury, which is a neighborhood within the city of Boston. Here we are looking at a 10-minute walking distance from the project site, which will be the local neighborhood that the project will serve, which is a very vibrant minority community, primarily African American Hispanic, rooted in community, faith, and family, but one that lacks in capital investment and one that most visitors or residents of Boston don't visit, as in the case of many of our urban minority neighborhoods. The project became possible as a result of proactive initiatives of the Elliott Congregational Church, which is one of the community pillars of the Roxbury neighborhood. And we became involved as a result of their ongoing partnership with Wentworth Institute of Technology, where I taught as an adjunct faculty for many years. The Elliott Church wanted to make good use of their primary resource, which was their building and land, to explore affordable housing for their community, and we identified a small site of around 3,000 square feet. It became very clear that the main church building was mostly off limits to investigating affordable housing, as it was on the National Historic Register, and given the impracticality and extraordinary expense of converting such a building type for housing. You can see some of the primary views of the housing site identified for our project. And looking back at the neighborhood, our analysis showed an array of vernacular small-scale residential typologies of light frame wood structure, such as the single family, the duplex, and the triple decker, on similar lot sizes that could benefit from our investigation of mass timber housing. Preliminary analysis of zoning and context studies resulted in a maximum build of 15 to 16 units for a 4-story structure of 12,600 gross square feet. In addition, cost parameters ranging from $300 to $325 per square foot was established, consistent with City of Boston guidelines for affordable housing. Given these parameters, we were ready to explore the use of nail laminated timber for the project. To make best use of NLT, taking into consideration carbon storage, structural efficiency, design flexibility, and potential to expose the wood for a biophilic effect, we decided on the use of NLT for all of the floors and roof, as well as an inner core walls in a structural grid width of 14 to 17 feet wide that would allow for 2x4s and 2x6 lumber, less expensive than 2x8 or 2x10s. These NLT floors and walls would need plywood sheeting on one side to provide continuous structural diaphragm for the floors and lateral shear capacity for the walls. We had to follow the unit size guidelines established by the City of Boston to be eligible for city funding, and configure such units within the NLT structural framework we established, consisting of 2 one-bedroom, a 2-bedroom, and a studio, so 4 units per floor of various sizes to accommodate a wider array of residents. And on the ground floor, which we see on the left, we eliminated one of the units to allow for an entry and a common space. In addition, the layout consisted of the smaller circulation core of a single stair, an elevator for equitable access, and a compact hallway to maximize the housing unit areas and to keep the grossing factor as small as possible, and to allow for the perimeter for the bedrooms and living rooms. By working within a small span structural grid and containing the shear structure to the core of the building, this allowed for the design flexibility of various roof profiles and facade arrangements to maximize larger corner windows where the main living rooms of all of the units would be located, as we envisioned the project to serve as a kind of prototype for similar small-scale developments on empty lots of similar sizes all around the neighborhoods in the city of Boston, as well as other similar urban centers. So we see here a bird's eye view of the project with the roof profile and window configuration we selected given the site conditions. Here a roof profile which has a peak towards the taller building, the church itself to the right, and has a lower roof adjacent to a smaller scale duplex, a triple decker duplex in that case, to the left. And conceptually, we identified all of the structural mass timber components in conjunction with the typical light frame wood construction and the rest of the architectural building assemblies. And in looking at the carbon storage benefits across the construction type, lumber used, as well as other wood products, our approach resulted in twice the carbon storage for project consisting of NLT and light frame as compared to the typical all light frame building approach. And we envisioned a construction process similar to those done for light frame wood with small local contractors, with added efficiency of prefabricated NLT panels and stud wall assembly, flexible enough to be adapted for a specific site in an urban neighborhood, and in our case, the ability to use an empty parcel on the church property to be able to make NLT panels on site in sizes small enough to be hand delivered to the building site. The resulting project then is clad in charred wood to reduce maintenance and increase the durability of a wood cladding system, but one that could take on a different cladding material on other sites. The interiors of the units would be light-filled given the larger corner windows in the living rooms for all of the units, along with the express warmth of the exposed NLT core walls and the underside of floor panels in the ceiling plane. Bedrooms would have at least the ceiling plane with exposed NLT panels with careful arrangement of light fixtures and sprinklers on the side walls to keep the ceiling plane clean, as we did at our Adobe Hall project. And even the lower level units, while not having the lofted higher ceiling heights, would also benefit from the exposed NLT throughout. So in conclusion, we go back to the crisis of carbon emissions in our environment today, and as we've made good strides in the recent years in addressing operational carbon with an array of renewable energy such as hydroelectric, geothermal, solar, and wind power for much of our building, heating, and cooling needs. In addressing the embodied carbon, that is the carbon emissions related to the construction of a building before on day one when that building is occupied and in use, we understand that as far as we know, wood is the only renewable building material. And until some brilliant scientists one day might be able to figure out how to grow concrete or steel, that we have to reduce significantly our carbon emissions if we are going to address climate change. And because statistics show that more often than not, it's the minority communities that are the most adversely impacted by the results of climate change, it's not only sustainable to build with wood, but but that I would make is that it's a just one, that it is just and equitable to use mass timber for housing for the least privileged among us, that they may thrive and enjoy better housing and not continue to shoulder the burdens of climate change. So thank you for listening, and I look forward to our panel discussion.
Thank you, Tom. More great information on mass timber and affordable housing projects. To continue this conversation, let's finish up with Susan Jones.
Hi, everyone. This is Susan Jones from Seattle, Washington, and I'm really thrilled to be here talking to you all as part of the 2022 National Products Week. I'm an architect here in Seattle, and I lead the small firm, all-woman-owned firm of atelierjones. We've been working with mass timber for about a decade now and consider ourselves leaders in the US. And we have a really exciting building project to share with you that I'm really excited to talk about later. But our journey didn't begin here, and it really began with our CLT house that I'm sitting in right now. It's a small house built for a family in Seattle, and it was built out of CLT. It was one of the first houses in the US, and it really began, as you can see from the screen, to start me on this journey to understand the logos, the study of our house, which of course is our house in very much depth and detail, but also the house of our earth, and it stands for ecology. This process has been a really beautiful process, and as leaders in the mass timber world, our little firm has been huge leaders in the world of mass timber for over a decade. Starting with our house in 2010 and 11, when we started designing it, I got involved with a beautiful church, mass timber church, and a couple years later, a few schools here in Washington State. And because of all that early work, we were asked to join the Mass Timber Code Committee, sponsored by the International Code Council between 2016 and 2019. And we passed those tall timber codes. And now my firm is building one of the tallest mass timber buildings in the US. I think I heard it was one of 15 in North America, and it's workforce housing, and it's here in Seattle, Washington, and I'm going to show it to you later as we move forward. We've been really proud of this journey and really excited to share bits and pieces of it with you. But of course, this all starts in the forest, and this is National Forest Products Week after all. And we know this dichotomy between this old growth forest that's on the left and the extraction of the logs and the round logs that come out of that forest on the right. And that interplay has been a really active force in our Pacific Northwest, as many of you know. And it's really exciting to me to be part of the leadership of the mass timber world as it starts bringing these products to higher value products to market and helping our rural communities all over the country to rebound and restore their communities and our forests as we move forward. Because as you know, the forests are not in the best of shape in many cases. Many cases they are, but these are some of the more dire cases. The one is on the left, which is my own family forest. And I'm kind of always ashamed to show this, but because it's a very badly overstocked, not healthy forest. And we've been working on this with our Department of Natural Resources in Washington State, and it looks a lot better than it does on the left. But I don't need to tell you and all of you about the forest fires as exemplified here on the right. Our forests are in a bit of trouble, and we need all the resources we can possibly get to help make them healthy and preserve them for the future. And that's one of the reasons I threw my hat in the ring to help change these codes for mass timber, to build taller buildings at scale, which will help sequester the carbon in those buildings, but also help substitute for higher carbon buildings in the environment as we move forward. So we spent about 3 years redesigning those codes to allow for mass timber at a high-rise scale, at 9 stories, at 12 stories, and at 18 stories, all over the US in jurisdictions that adopt these national tall building codes, the ICC codes. And so in the IBC 2021, we can now expose the timber all up to 9 stories and much of the timber up to 12 and build 18 tall, high with wood, which is amazing to me. We were inventing new kinds of building types, and it was an exciting process to begin to rethink how you would build a high-rise out of wood and do it safely. We were involved in a lot of fire testing that the forest industry helped helped promote and sponsor, and this was done outside of Washington, D.C. at the Bureau of Alcohol and Tobacco and Firearms. And I had never seen a fire test, and so to see 5 of them try to burn this 2-story building down 5 different times with the amount of heat that was generated from those fires was incredible, and the buildings didn't burn down. It was one of the key turning points in our quest to prove that tall mass timber buildings could be built safely. And so we passed those codes. This is a picture of a kind of a stressed out me in 2018, testifying for the IBC General Committee action hearings. And I am happy to say that we did win that battle against some really strong forces, as some of the other products like concrete and steel were pushing against us at the time. And we were successful, and now those codes are law. This is a picture of me with our wonderful Governor Jay Inslee, really signing those codes into law in our Washington state just a few months after we passed those by strong margins, and you can see that on the left. It was a thrilling day for me when those codes passed. And now that impact is really beginning to show with these kinds of buildings that we can build. The one on the left is the 8-story mass timber, type 4C, type 4B in the middle, 12 stories, and type 4A. And you'll notice that you don't see much timber in type 4A, but that's because the codes, we had to make some compromises to cover some of that up. And I think this is where we do need some more forest testing, fire testing particularly, to advance our cause to allow that to be exposed and to have less costly and less carbon intensive gypsum wallboard as the covering for those pieces of timber. Because as I know deeply, those codes have been very conservative. So this is one of the reasons that we also, as a small firm at atelierjones, investigated under the aegis of the Nature Conservancy and the University of Washington and the U.S. Forest Products Laboratory and Woodworks. We helped develop some LCA studies that were just published a year ago, and it was an extraordinary effort to really help prove that these buildings were significantly less of a carbon footprint than their contemporary compatible comparisons, up to 43% less for an 8-story building, and a little bit less, say 30% less up for an 18-story. And that's because of a lot of that gypsum wallboard, which, as I just mentioned, we feel is sort of unnecessary. But these carbon studies are very critical to help prove that point. And we all know how important it is to help lower our carbon footprints in our building industry across the country. The fire testing that we engaged in for the next year, this is version 2. I was involved with a grant that was funded by the U.S. Forest Service, and very gratefully so, to work with the RISE, the Research Institute in Sweden, to help that fire testing prove again that the codes are too conservative and that mass timber is safe. And we again built five structures over in Sweden, this time in an outdoor arena. And yes, we tried to burn them down 5 times for 4 hours with no sprinklers, and they did not burn. And so these are the kind of research effort that I feel really strongly needs to be continued to prove and to bear out that these structures are safe, and that we can contain any fire that might occur within that compartment, and therefore the structure of the building is safe in the future. But the impact from that last fire test was yet another code provision that allowed us in 12-story buildings to at least expose the ceilings up to 12 stories, which was a very exciting advancement. So we're making progress on a yearly basis, year in, year out, thanks to the research which is funded by the U.S. government. And now today the codes are active, the buildings are active. There are 15 very tall buildings, that is 8 stories and above, around the North American continent that are built or in construction. And this is one that's in Milwaukee. atelierjones did not build this. This was designed by Corp Architects. And you've probably heard a lot about it because it's pretty dang famous. And I always forget if it's 27 or 29 stories tall, but it's pretty darn tall, and it sits over a concrete podium of 7 stories. And yes, it does expose all of that mass timber. In the opinions of the jurisdictions, it's pretty darn safe to do that. And as you can see on the right with the finished photo, It's an amazingly beautiful environment to be stunning, sitting over the skyline of Milwaukee, looking out to the skyline and sitting in a wood building in your own home. An extraordinary achievement. But I'm going to come back to Seattle and talk about this little parking lot that looks kind of humble here, and it is a humble building. It's a project that we call Heartwood, and it's owned by a nonprofit called Community Roots Housing, which also owns this building, this brick building that you see on this slide. And they provide housing for people who are making under 30% of area median income, which is still quite a high number in Seattle, but it's really important to begin to provide housing for this group of people. So we were asked in 2019 to begin to design a building that would fit on this parking lot, and very happily we had a grant from the U.S. government again to begin to design this building. The building sits on this site in Union Street and 14th. And for those of you who don't know Seattle, which I don't expect you would, it's kind of it's near the downtown of Seattle in a place called Capitol Hill, which is where a lot of the hip and happening hipsters are staying. And it's now under construction. This is this little brick building here, and there's this new building here, and we're building a courtyard that combines those two areas. The plans are very simple, and I won't go into all the geeky wood details that we do sometimes with audiences, but I want to say it's 126 units. It was a very powerful team that we had together. It was highly collaborative, and that was in part thanks to the grant. We were able to bring this high-powered team from the very beginning all together. And it included ourselves, atelierjones, DCI structural engineers and civil engineers out of Portland and Seattle. Our owner was Community Roots Housing, and their developer rep was Skipstone. We then partnered up with Weiss Jenny Elsner to do the fire protection engineering, and Greenbush Acoustical to do the acoustical work, and then brought on our partners, Swearton Builders, who was a contractor, and then worked with Timber Lab, who was the timber post-processing. The timber came from areas that were around the Cascadia area, from Kalishnikov to D.R. Johnson to Ferez lumber for MPP stairs. This is the building as it was rendered. It stands 8 stories next to another brick building on a fairly busy street in Seattle, Union Street here. And we're really excited that it can bring the kind of density that we've been hoping for in Seattle to provide more workforce housing units, which, as you know, is a critical issue, not just the affordable housing market, and certainly not the market rate housing work, but this kind of missing middle of how do you provide for people who have decent jobs, but the salary rates are not maybe matching up with our tech stars here in Seattle, which we know and love, but really their salaries do exceed those of teachers and dental hygienists and bus drivers, etc. And they need a place to live as well. So this is trying to address that missing middle, and it was a complicated funding strategy because it received no public dollars other than the small grant of, I should say, $250,000 grant was a pretty generous grant to get this jump started. And that process really worked. It was really exciting to have that seed money that really catalyzed this project forward. A few more images of the project. It's a rather humble project. It's a lower cost project because of the workforce housing. It has a simple fiber cement exterior, and all of the exterior materials, because of the code that I helped write, need to be non-combustible. So while this may look like wood, it's wood superstructure, but it's not wood on the exterior. And that's an important thing to see. This is some of the small spaces that are now under construction in between the buildings, and that's been really exciting. Some of the ways that the space move into, and these small units that work out onto this area, and an idea of the lobby as you move it across the courtyard, and that courtyard, of course, is shared between those two buildings. This is one of the more exciting images of the project, and this is where you begin to see the impact on these units and on the inhabitants of the units. And this was really one of the reasons that we pushed this project forward. They're small units, they're studios, they have a bathroom, they have a full kitchen, small kitchen, and then there's a bed that's part of the living room that has 2 simple windows that see out to the city of Seattle beyond. And in that unit, there's an exposed column, a wood column, glulam column, and an exposed wood beam, and there is a exposed wood ceiling that's happening on the ceiling. And it's an exciting version of that project to move forward on. But this whole journey of mass timber has been what I like to call sometimes as disruptive, and I mean that in a really positive sense, and I know that's kind of a trendy term sometimes, but I feel, and I'll show you examples of that, that we are really disrupting the forest products at laboratory, and it's really working in a very positive way to bring prefabrication and other elements. This superstructure is really where the future of housing with mass timber is going in the future. You can see it's all wood columns and wood beams, and it's all wood CLT floors. And this is working to structure the building and provide lateral forces. We're also using wood stairs down here, and we're using a concrete foundation as well. And it's a very exciting thing to begin to think about how different that is, because this superstructure is about, as I said, 43% lower carbon than anything else. It's also really exciting because when you really think about where we think about where that timber comes from, it came from a geographic area which is very much regional and in a regional biology, ecology, biome necessary way, from D.R. Johnson to Ferez, and yes, Canadian CLT panels up in Kalashnikov. I will say that we had hoped to work with Katerra here in Spokane, but they were not able to end up working with us because they were out of business at that time for other reasons that I think are really unrelated to the mass timber industry. And so we ended up working with a great supplier that does their local forest harvesting called Kalashnikov up in the Kootenays, BC. That regional timber sourcing is one of the hallmarks of atelierjones' mass timber work, and we tried as often as possible, and I would say it's been 100% possible to source within this regional Cascadia area, and I'm very, very proud of that. One of the other things that's really exciting about using mass timber is that you can quantify the volumes of concrete, the volumes of timber, the volumes of steel, and really begin to do some careful work on terms of what is possible between for the carbon calculations. And so these LCA, these life cycle analyses, can be done very precisely because in part of the technology that we need to use to create these buildings. And it's a really exciting thing to be able to be very exact and not just, oh, it feels like it's less concrete and carbon, but it's actually, it is less carbon, and that can be proven out through these life cycle analyses, which are a very powerful tool. Some of the other things that we think about in terms of this disruption of the construction industry is how do we work with the prefabrication processes? How do we work in an integrated team? And I'll talk about that a little bit later. How do we lay out these panels that are all going to be prefabricated? These were early drawings that we were trying to reduce the amount of oversized panels because we were thinking about shipping, and we were thinking about the crane that's currently on our site right now and how many picks, crane picks they're called, it takes to pick up a panel and put it on the project, on how we can reduce the numbers of those as we go forward. And those are the kinds of things that really change the way we design, and we're happy to embrace those notions of how we move forward. But this integrated delivery has been one of the most powerful elements. We work early on with our contractor, we work early on with our timber post-processor and the panel suppliers, as well as our mechanical, electrical, plumbing engineers and contractors. And we create a big BIM model, building information model, that has all of that information together. So right from the very beginning, we're understanding how we can reduce the amount of soffits, which means that we can reduce the costs because of these soffits are always an extra cost. And most importantly, we can increase the area of wood for the project. Lots of innovation happened for how we build these 2-hour connections, and I won't go into all the geeky details about this detail, but it's a really exciting detail that we developed collaboratively with our partners at Timber Lab in Swinnerton and Weiss Jenny and DCI engineers to develop this really cutting-edge, very highly developed all-wood connection between columns, beams, and CLT. And that leads to this notion of this housing project being replicable. And so you can take this superstructure. This is a live BIM model from ours, a live Revit model, and that's just the superstructure with the services integrated into it. And we can now take this model and begin to repeat it on different sites with different designs, with slightly different dimensions and slightly different unit layouts, etc., and still capture all of the intellectual property that in the layouts and the details, etc., that was working for this project on our network in my small office in Seattle. And I'm really excited about the future of doing this because, as you can see here, this project is going very fast. This is another piece of this disruption. I want to show you, I'm kind of showing off, I guess, because 2 months ago, actually, it's only been 6 weeks if I really do the math right. 6 weeks ago, this project was 1 story. And then now I came back to it, and it's this 1 story. That corner is that corner. You can see my name there, our firm's name, and you get 1 story, 2 stories, 3 stories, and 4 stories. This is actually the floor of the 5th story. And so we've been able to go up to floor 5 in just under 6 weeks. It's an extraordinary achievement. This is the same picture as an aerial, and you see the columns and the posts and beams that are in there. 1 of the panels has been placed, and now we're 1, 2, 3, 4. The 5th floor of the 5th floor has already been placed, and I just took that photo yesterday from our webcams that we have on site. It's an extraordinary, I'll just show a couple of how beautiful the wood is. This is the MPP product from Ferez for the exit stairs. Everybody says, well, this is a lovely feature stair. It must have been more expensive. Nope, these are the exit stairs. They're right behind a little exit corridor, and they'll be there. I want to talk just to conclude quickly, though, about some of the importance of the work that we're doing for our forest fires community and a small little nonprofit pro bono project that we're working with in the Sierra Nevadas for the nonprofit Sierra Institute. And they had a devastating action that happened in 2020. Their town of Greenville, California looked like this, with 600, 800 houses. And after August 21st, 2021, that town looked like this. There were over 600 houses that were destroyed, and everybody in the town was displaced. And the Sierra Institute has been an amazing partner and reached out to us to begin to rebuild that community. The devastation was very real. This was a house site. You can see the walk, you can see the sidewalk. I'm standing on the curb. This is a house site that used to be here. And you can see this really kind of sad sign, but pathetic, full of pathos, saying, we're rebuilding. And this is a family that is committed back to green build. And we are working with this organization to help provide housing for families like this who own land in Greenville. We have a very small, humble effort. Right now, we have 3 houses under construction, which are going to be built very shortly, but we're also working with the community to again build hope and to bring some of these logs out of the forest that are burnt, and we're still providing great lumber to help with Sierra Institute to build a mill and to have this community shed that will be able to show some of the projects and the ideas for the future houses. And so these are 3 houses, very simple houses that are under construction. And we're using modular wildfire hardened projects and strategies to help work with this, including a modular wet core, we call it, that is in the center of each one of these houses, including the fabricated timber for the houses themselves. And these small little simple houses are between 600, 800 and 1,000 square feet. They can be built very quickly. And it's really so much in part because of these off-site production methods, when we're having much of the complex construction and systems for these small houses being done off-site in a factory up here in Ferndale, Washington, and then shipped down I-5 on a flatbed truck to arrive in the Sierra Nevadas to look like this. And we're hopeful that this will be finished. This was a picture from July. This is my office here, and we're visiting the 3 mods that we drew up in about 3 months. And then now they're in construction for 3 months, and they'll be down on site. In fact, I think they're arriving on they've already arrived on October 5th, which is really exciting. This is the base down the Sierra Nevada of this small 600 square foot house, and we'll be putting that wet mod on top. And so just in closing, I want to just say how powerful it is to be able to speak to you all and to be able to be involved with this mass timber world. We feel that our small firm of 6 people, this is half of our firm on site at our Heartwood site just a few weeks ago. We understand how impactful we've been and what the future holds for this industry, how we can replicate this 66,000 square foot mass timber building, and we can't wait to do it again. Thank you very much for your time, and I really appreciate your attention. I'm looking forward to any questions that might come up. Thank you.
Thank you, Susan, and thank you to all 3 of our panelists. We're going to switch over now to the live question and answer session. All right, so actually before our question and answers, we have a short video that we're going to play with Jason McLinn of Community Roots Housing discussing why they chose mass timber for the project that Susan just discussed, the Heartwood.
There's a serious housing crisis here in Seattle. We need to provide more affordable homes in our communities. That's our mission, that's what we're doing, and that's what this project is about. In real estate, we're always looking to get better, find more innovative ways to deliver product faster and more affordable. Deciding to go with mass timber allowed us to have a win-win situation. We were able to increase density. We're delivering almost 50% more units just by choosing this method. Community Roots Housing is a community-focused affordable housing developer based in Seattle, Washington. We have over 45 apartment buildings serving more than 2,000 residents throughout the Seattle area. Workforce housing is affordable housing, but it gives us an opportunity to meet folks who are traditionally missing out on opportunities to have affordable homes. And they're being priced out of high market areas like we have here in Seattle. We're talking about your teachers. We're talking about our first responders. We're talking about two family households who are just trying to get by. They're able to stay closer to work, schools for their children, family. This is a very sustainable product and helps us to fulfill our commitment to being environmentally friendly. The very nature of wood is that it stores carbon. Mass timber uses less energy than concrete and steel. We estimate that we are reducing our carbon footprint by approximately 40% as compared to more traditional construction methods. It was built virtually. We were able to look at the entire building from a 3D perspective. The building is fabricated off-site to precision. It's nothing like seeing that timber flying. Then I feel like a kid again, reminding me of my Lego set. Putting the building together piece by piece, floor by floor is one of the coolest things you can see. Mass timber just creates a warm and inviting feel. There's just something about seeing that exposed timber that just brings a nice feeling. This project has been wonderful. It meets so many of our key objectives at Community Roots Housing. But the day I'm looking forward to is the day we welcome our new residents at Heartwood to their new home.
All right, thank you for letting us show you that, and I hope you enjoyed that as much as we did. And I am going to pass it off now to Lori and our panelists for questions and answers. You all have been giving us a bunch of questions, which is great.
We've been getting a lot of questions, and thank you everybody for attending today and for your insightful questions. And we're gonna jump right into it. First off, thanks to our panelists as well for your great presentations. So our first question, and this is a question that I feel like I get asked similar questions on this topic. This one's going to be for Kevin. So why is the U.S. Forest Service supporting mass timber? How does building with mass timber help the forests? Aren't we cutting down trees?
Yeah, that's a great question, and I'm glad that question was asked. So our forests, and when I say our forests, it's not just the national forest, it's private land forests, it's state forests. They're in a kind of within the United States, they've become overgrown. There's actually too much timber on the ground. So what we need to do is we need to manage our forests in a way that bring them back to being more ecologically healthy, right? So we have, one of the reasons we have fire risk and are having such catastrophic wildfires in the West is we haven't had markets for wood, so we haven't done management. We haven't gone in and thinned. Most of our forests are too dense. So I think one of the reasons we support opportunities like mass timber is we're trying to be able to create wood markets that we know that will kind of be there for the long term. And we think mass timber is one of those opportunities. So no, we aren't cutting down our forests, not in the United States. We have an abundance of forests. We actually have a positive net growth of forests over the last several decades. So, but we do need to do more work. And that work means we need to go in and we need to cut, we need to thin, we need to kind of open up our forests to be able to allow for healthy water, for wildlife, and for people to be able to use. So using wood and managing our forests is actually positive.
Absolutely. Well-managed forests are productive forests, are healthy forests. So that's a great answer. Thank you, Kevin. All right. This next question is going to be for Susan, because I know she showed her picture at the ICC code hearing, so I know she knows the answer to this question. What's the definition of mass timber? Is there a code definition?
Yeah, that's a great question, and something that, interestingly, the Code Committee had to spend a little bit of time on, because as you saw from Tom's presentation, he built a project out of NLT, and then I used a lot of acronyms that were also like, okay, CLT, which stands for cross-laminated timber, and MPP, which means mass plywood panel, but then there were also glulam columns and glulam beams, and all of those are examples of mass timber. And I know for those of us who have been around in this industry for a while, that a cross-laminated timber was one of the first arrivals on the so-called scene from Europe in the North American continent. And so, I confess I was one of those too. Like, this is all about CLT, but as I learned more back in 2013 and 14, it's really about these family of these products. And yes, we do define those in the building code, and it's really important that we do, because as you know, a product that is not defined cannot be regulated. So it's important that we did understand that, and we agreed on what those definitions were. And they were partly product based, but they're also dimensionally based. And I'll stop there from getting too geeky on this call, but thank you for that good question.
Absolutely. No, I could have listened to you talk for all day. All right, here we go. So many questions, and they're all really great. Okay, here's a question, probably more geared towards Tom and Susan, but Kevin, if you would like to contribute, please don't feel stifled. We have a attendee who's interested to know more about the benefits of building with tall mass timber for health and equity benefits for residents. What's the latest on biophilic benefits? And for those of you who might not be familiar with the term biophilia, that's that warm feeling you get when you walk into a room and it has lots of wood all around. What is the latest on biophilic benefits of building with wood, and does this influence why you might choose this material for public housing?
Yeah, I would just say, maybe I'll speak generally, and then I think Susan, who's much more knowledgeable about me about tall wood buildings, could add to it. I would say, regardless of the size or the scale of buildings, I think there's three primary reasons as to why we would use mass timber and wood structures. One is obviously the sustainable benefits, the environmental benefits. Two is, as Susan showed, in terms of the ability to disrupt construction in a more precise, efficient, cost-effective way. And then the third is the atmospheric or the experiential benefits of exposing the wood and taking advantage of all of its biophilic aspects, which are basically all of the qualities of wood: visual, tactile, smell, all of those things that really, I think, enliven our senses in a positive way. And so in terms of, I think, generally the most public react favorably to wood environments because of its rich texture. It's not a stale environment like drywall, Hawaii drywall. It has got a fresh pine scent. It's warm to the touch. So in many of these ways, it's anecdotally and experientially proven across a large swath of population. And I think probably a large part of that has to do with the fact that it comes from wood comes from trees, and it was once a living organism. And it shares many of the characteristics as along with us. And recently what's happening is that these anecdotal statements of experience are being backed up by experimentation and data, so that studies are starting to come out in terms of looking at a wood environment, comparing that with a drywall environment, and looking at schools that do data and testing in terms of how much productive students are in terms of their test scores, and really, I think, gathering that data information. There's other really important cutting edge research that's being done in terms of the fact that wood is a hygroscopic material and that it can absorb and regulate moisture, that actually wood spaces take out humidity from the environment when it's very humid, and then when it's very dry, it'll release the humidity back, so that it really adds to the comfort of our spaces. So what I think many people understand experientially in a common sense way, through these data-driven experiments and much of the sort of the more scientific data related to the benefits of wood is coming to light now.
Tom, that was a really great answer, and I don't have a lot to add to it. You referenced a lot of series of studies, and I am not an expert on the most current up-to-date academic biophilic studies, nor would I want to claim to be. But I'm sure for the person who asked the question, that the AWC and especially Woodworks can put you in touch with some of those studies that have been released. My recollection of them, having looked at them, was that they do underscore the biophilic qualities that we all intuit from wood. In a really strong way. But the one thing I can add directly is that it's really been a part of our work in the code area, especially in this more recent 2020-21 fire test cycle through the RISE tests that were funded through the U.S. Forest Service through AWC. We were doing those tests primarily to understand the impact of fire safety, but also to take as much as to provide research to take the gypsum wallboard off of those areas of the interior compartments of rooms, of studios, of apartments, of student housing, of office buildings, etc. And what we found is that a tall timber at any area, that those were safe, of course. And so we were able to change those codes through a code amendment that I wrote in 2020 and 21 and passed in 2022 in January of this year. Was that the code community backed us and felt confident that we could take the gypsum wallboard off of that ceiling up to 100% of the floor area, which was a really exciting advancement, because as we've experienced in North America, that if you're going to build with timber, people want to see it, and it's almost like if you can't expose it, I think there's a reluctance potentially to that market to using those taller buildings. So now up to 12 stories, you can see 100% of the floor area of the ceilings, which is really exciting. And we're confident, in fact, it already has jump-started a couple of taller timber building projects because of that very essential and a very basic human need to see and be with the wood and breathe it and see its natural changes over time as it adapts to humidity and interior conditions, and just be around that wood environment. So it's a great question. Thank you.
Thank you for that. Oh, please go ahead.
So my answer is a little different than both Tom and Susan. So one is, if you haven't been in a building that's been built out of mass timber, you should do that, because it just walking into it will change how you feel about the difference between mass timber and other materials. And then the accelerator project, the Boston Accelerator Project, which Tom said he was a part of, all of the participants presented on the buildings. And they were in the architectural firms and the developer firms. They hadn't been exposed to mass timber before they started on that project. And by the time they had kind of finished that accelerator project, when they had done renderings of both buildings with mass timber and without, it was kind of jaw-dropping for the participants on just the difference between the two buildings. It was like, why would I build anything else? Certainly money comes into this, but just as far as the look and the feel, watching the impressions of people who hadn't been exposed to it was actually pretty powerful for me anyway.
Absolutely. Thank you for that as well, Kevin. It's hard to put words to it. Sometimes you just need to experience it. On that topic, Kevin, you were talking about cost. I think, Tom, you may have shown some cost figures in your part of the presentation, but we had several questions, a lot of questions actually, asking about cost. How does the cost per unit compare to other structural materials? Is mass timber more expensive? Is it cheaper? Why would you choose it for your project besides all of the benefits we've already talked about?
That cost question is probably the number one question that I get asked all the time. And I think the shortest answer is it depends on a lot of variety of factors. I would say that there is no inherent reason why mass timber should be more expensive than steel or concrete or other typical traditional modes of building. I would say historically, looking at the past 10 years, when you look at some cases where mass timber has been more expensive, it's not the inherent nature of mass timber, but because it's a newer construction product. And so like anything else where a different methods of building has been in place for 7,500 years, those efficiencies and all of those aspects, more suppliers, more contractors having experience, all of that has had years to mature. And we're just starting to begin, really, I think, our journey of mass timber in the United States. But even with that, there's been, with many of the reasons that Susan, I think, very well said, it's proven to be less expensive in many key buildings. One I could think of is the Brock Commons, which is the 18-story mass timber building, because of its prefabrication and modular array of elements. It was so much faster to construct than steel or concrete, and because of that, the time savings and the cost results was a less expensive construction. So I think it really depends, and I think that there's certain key things such as using modular components, and so that's why project types like housing is, I think, so well suited, and you can see how Susan demonstrated that in her project. So it's a complicated question, but one in which I would say the mass timber can be less expensive, competitive, or slightly more expensive, depending on a whole set of circumstances.
Those were great answers, Tom. Yeah, I agree with all of them. It does depend, which is not very satisfying, I know, to the people on the call. But one of the key factors, and my experience has completely borne out what Tom says. When we did the early cost estimates for Heartwood, it was slightly more than a traditional concrete 8-story building would have been, but because it was only slightly more, we felt it was early in the process, and we had a very experienced team. We felt it was worth pulling that trigger to go forward on this, and it's proven out to be through a lot of very careful, hard work by the entire vertically integrated team, from Swinnerton to Timber Lab to DCI to atelierjones to the owners, to be, I would say, quite competitive with a standard building. But a lot of that depended on, as Tom mentioned, the schedule. Because we are able to optimize and accelerate the schedule faster than a light wood frame building, faster than a concrete building, certainly, or concrete and steel, we were able to make great schedule changes. And now, of course, advances. And of course, you can't count on that when you're back in schematic design or even more feasibility study, which is where we were when we were making these claims. It's really hard for an owner to say, great, it's the same or maybe even slightly more, because the material costs at this point in time, given the supply chain, are potentially a little bit more expensive than a concrete building. Even at 8 stories, 9 stories. However, we're going to make it up to you at the back end on the schedule. Like, it's a rare owner that's going to really say, okay, cool, prove it to me. And then I'll, if it's wrong, then I'm stuck, right? And I think this was really one of the most extraordinary pieces of this ownership team. And I have to really credit Community Roots Housing and Skip Stone Development for making this case clear. But we couldn't have done it without the strength of our team as a very experienced and able team that understood the intricacies and the differences in making mass timber real. Swinnerton Builders and Timber Lab, I can't say enough about both of them. They were awesome in terms of making those schedule savings very tangible and explainable and understandable, even in the early days. And now seeing that all come together on site, the prefabrication is a huge part of it. And if you think about those diagrams that I was showing, we had prefabricated superstructure, all of the mass timber structure, but also the steel lateral system was all prefabricated. We didn't mess with a concrete core. We just had a very slight, small concrete foundation, which was, of course, site built. But most of the rest of the building, except for the interior finishes, are prefabricated, including the prefabricated wall panels, which are going in as I speak on floor 2, 2, and 3 right now. And we were able to make some additional advancements in the schedule on that. And my expectation is that we will continue that trend with prefabrication to bring in some of the wet cores, the kitchens and the bathrooms as prefabricated elements the next time we go through. Although we probably won't go volumetric modular. I don't think it makes as much sense with this technology. And anyway, we don't like to ship air, transport air down our streets, but it just gets expensive and wasteful. But I can say that the project is a similar cost comparison to any other project going up in the area of the King County in Seattle, which of course has some very expensive labor costs. But then again, they're less than the Bay Area, so it's kind of hard to throw out a number, because some of you might say, wow, that's really cheap, and some of you might say, wow, that's really expensive. And that goes back to Tom's answer, which is, it depends. So thank you.
I want to just add one thing to what Susan said, which is really super important, and it's that notion of vertical integration and that collaboration that Susan and her team had with the supplier, the builder, the fabricator, all of that. And she showed a slide of that connector which had no steel, and that is such an innovation because oftentimes in mass timber buildings, traditionally you'd have a lot of steel connectors, and sometimes with ease of assembly, a lot of more expensive proprietary connectors. And so that's highly inventive detail that she showed is practical, it's cost efficient, and it takes the kind of the steel element out of it, which is, as we all know, a lot more carbon emission than comparing it to wood. And when I saw that detail, I was like really, really amazed at that invention, because those of us who are sort of wood geeks know this famous example of Shigeru Ban and Bloomer Lehman and the Temedi office building, which takes away all of the steel connectors, and it's all wood joint, but does it in a way that only like a Fortune 500 company can afford that type of a detail. What Susan and her team has done is take that notion of taking the steel connector out and make it affordable and accessible to nonprofit everyday buildings. So Susan, I've been a long admirer of your leadership in mass timber, and real kudos to you for that invention there.
Oh, Tom, thanks, man.
So if I can add, so I will say both Tom and Susan are pioneers and leaders, I think, in mass timber. So I think that's one of the reasons they're on this panel. And they have a considerable amount of experience and knowledge. But there are a lot of architects, engineers, GCs, developers that are inexperienced or new to it. And so that I had in my presentation, I had talked about Woodworks, and they are a partner of ours that we and the Softwood Lumber Board help fund. So they provide free consultation. They're very knowledgeable technical experts that can be able to help if you're new to mass timber, to kind of get through the learning stages, to be able to help you better cost and understand working with mass timber.
I couldn't agree more, Kevin. And I want to go back. I was thinking back to, like, I don't know, 2013 or something, 12 maybe, when I went to my first Woodworks presentation here in Seattle at the AIA, and it blew my mind. You know, I'd been tracking this and wanting to do it, and then I meet my structural engineer, and we go and build our house in 2015 or so. And those early touch points that Woodworks provides are incredibly critical to help answer all of the kind of basic questions, and then help you find your team, the integration of your team relative to your local area. And it's a very powerful resource that that I'm really appreciative of the USDA and the U.S. Forest Service for funding, because it's helped a lot of people get off the ground for mass timber.
Absolutely, and we will have some contact info for our partners at Woodworks before we close out today. They are certainly an invaluable resource for anyone who's either new or experienced to designing with wood for multi-family or commercial projects. They have a lot of great contacts and great experience. All right. Kevin, we're going to pivot back to you just for a minute, because I'm a outdoors person, and I like being outside and in the forest, and so talking about, you know, areas affected by forest fire. Someone asked regarding areas affected by forest fires, can those charred trees be harvested and used for lumber, or is the lumber altogether lost? Is that something that the Forest Service has engaged in at all in dealing with that?
Yes, we are. We have, as a matter of fact, last year, 5 of the grants we gave out went to small mills or small users in California that are trying to harvest wood from burnt out areas to be used for lumber. So we are trying to put, we've tried to, through our Wood Innovations, but also just the Greater Forest Service. Yes, we definitely want to be able to try to use lumber from areas that have been affected by fire. Some of that wood may be burned beyond, but that's not the case with all of the wood. Certainly, there's a time frame when you have to get in there and go and use that. But definitely, we try to use that wood. We have a couple of partners that are trying to reuse wood from fires and to build new housing for homes that have been lost to fire. So. We certainly want to be able to take advantage of that.
And that was part of the story of the Sierra Institute that I presented. We're currently just putting the mass timber panels on right now, and they were not made from the forest fire burnt wood. But when we were down there, it was very clear, and we were supporting an effort through California state funds to begin to bring in the wood that's burned faster and faster. And there's a local sawmill that's harvesting it and creating the Ponderosa pine lamstock that is not actually a merchantable product. And then the hope is that there'll be some funding in the future to help build a small, very rural CLT plant that will be used for the future homes that were now under construction with D.R. Johnson mass timber. So it's a longer term vision, but it's a really exciting one. And I can't emphasize that enough. We really need to create that circular economy, if you will, between the burnt wood and housing for people.
Thank you, Susan. And I, you know, that first question when we talked about, you know, cutting trees, is that, you know, for mass timber, is that bad? I want to go back to that if I can. So it sounds funny. I've spent 25 years doing construction before the Forest Service, and I came into the Forest Service, and so I've learned a lot. But in one sense, we actually need to cut trees to save forests. That's part of the issue of overgrown, dense forests that haven't been thinned or managed or harvested on both national and private lands because of a lack of markets. Is one of the reasons that has resulted in some of the issues that have caused our wildfire. So and I had the kind of, I guess, both the privilege of reading every state has a forest plan, and almost every state that has a forest plan talked about they have an overgrowth of small diameter and too dense forests because of lack of markets. So we do need to create more markets more opportunities to use wood for our forest in the U.S. to create healthy forest systems.
All right. Thank you for that the insightful answer. Thank you to all of our panelists. We're coming up on the half hour here, so we'll close things out here while Marcy transitions to the closing material. Again, thank you to all of you for attending our panel today. Susan, Tom, Kevin, great information. Really, we had the Avengers of mass timber, I feel like, present today, and it was really nice to just be in the room. So Marcy, are you ready to do our closing announcements and send everyone on their way?
I am. I love the Avengers of mass timber. That is awesome. All right, let's go ahead. So thank you again, esteemed guests, Avengers. Great information and photographs. I was right there with you. This is a great topic. Just a little more information. As we were saying, Woodworks, wonderful resource. They provide wood project assistance and other resources. Reach out to them at help@woodworks.org or visit their website at woodworks.org/project-assistance. And this concludes the webinar. Thank you for joining us. Have a great day.